So continuing on, using what we know now about the different types of trig functions, we can now use them to evaluate them in different scenarios, okay? So we have this new foldable. Let's talk about a little bit of vocab first before we go forward. In right triangle, trig, okay? When you have an angle that is in standard position, that basically means you're looking inside of a coordinate plane. The vertex of that angle is located at the origin, and its initial side is lying on the positive x-axis, always, okay? Because what you're gonna see, especially in this foldable, is that we're gonna be looking inside of the coordinate plane, and we're gonna have all these different angles whose initial side is always on the positive x-axis, and its terminal side is the one that's going to be located each one of the four quadrants, okay? Each one of the four quadrants. And it's going to create an angle, okay? The angle, if it's positive, always goes in the counterclockwise direction, okay? So for your angle, the initial side is on the positive x-axis, and the terminal side, if it's forming a positive angle, is basically moving and rotating in a counterclockwise fashion to create those angles, okay, in each one of the quadrants. If it goes in the clockwise direction, it's a negative angle, okay? A reference angle. A reference angle is an acute angle that lies in between the terminal side and the x-axis. It's always acute. Acute means what? Smaller than 90, but more than 0. Yes, you do need to kind of add in that stipulation because we can't talk about negative angles at this point, okay? So it's less than 90, but bigger than 0. So it's always acute, and it always lies in between your terminal side and your x-axis, okay? And I kind of went ahead and put in purple, as you can see around, because our initial side is on the x-axis and it starts to rotate in the counterclockwise fashion. If the terminal side lies on top of the initial side, it's 0 degrees. But as you go counterclockwise, 90 is straight up, 180 straight across, 270 as you continue to rotate in the counterclockwise fashion, all the way back to 360, forming basically like a circle. Does everybody understand that? Yes. So, trig functions of any angle. You can actually find a trig function of any angle. Any angle. If you let theta be any angle in standard position, in other words, origin, or vertex at the origin, initial side on the positive x-axis, and you let P be some point xy on the terminal side of the angle, R is the distance from P to the origin, like so, then you have all these different types of, not all these different ones, basically your 6 trig functions, and we can actually figure out each one of their ratios based off of this information. X is the horizontal distance that the point is away. Y is the vertical distance. And R basically is our hypotenuse in this right triangle. So in terms of this, sine of our angle, it's not opposite over hypotenuse, but Y over R. Does everybody see what I did there? Do you understand why I got Y and R? X represents that horizontal distance. Y represents that vertical distance that this point, whatever it is. So normally, sine would be opposite over hypotenuse, but in context of being inside of a coordinate plane and a point is in standard position, an angle is in standard position, it's Y over R. Cosine would be, what you think? X over R. That adjacent side, X, over the hypotenuse, which is R. And tangent would be what? Y over X. Technically, that opposite side of that angle, which is Y, over the adjacent, which is X. Cosecant, secant, and cotangent are the reciprocals, which means we need to do what to each one of these? Flip them. So cosecant is going to be r over y, secant, r over x, and cotangent, x over y. So it's still pretty much what we were doing before. It's just now you're just taking it, applying it to any point inside of a coordinate plane with an angle that's in standard position. Okay? We can still find the 6 trig ratios of any angle this way. All right? Questions? Then we'll keep moving forward. Now let's get to the evaluating. Let's get to some fun parts, okay? There are 5 steps for evaluating trig functions, the specific types of trig functions, okay? These are ones of any angle, all right? You want to draw the angle in standard position. Standard position means the initial side should be where? On the positive x-axis. Your terminal side should be in one of the 4 quadrants, depending on what the angle is. Then you need to pick a point P that's somewhere along that terminal side. And then from point P, draw a perpendicular segment to the x-axis. Notice that a right triangle is formed. What does perpendicular mean? It creates a right angle, hence a right triangle. Then you need to determine the reference angle and the length of each side in the reference angle. And of course, adjust the signs as needed. Lastly, find the trig function. Now looking up for you, you guys have all those steps side by side to these 2 examples that we're about to do. What's step 1? Draw an angle in standard position. So standard position means that my vertex should be at the origin. The initial side should be on the positive x-axis. And then my terminal side should be exactly where 120 degrees is located in a coordinate plane. And if we're going in the counterclockwise direction, 120 degrees lies in what quadrant? Quadrant 2. Let's review that real quick. What quadrant is this? This one? This one? And this one is? So it makes a C. Okay? So 120 degrees would lie in between 90 degrees and 180. Okay? So this right here is how you would technically draw this 120 degree angle. Does everybody see what I did there? So that was step 1. What's step 2? Pick a point P along the terminal side. It doesn't really matter where. I'm going to put mine a little bit further out because I do write kind of big and I want to make sure I have enough space to show everything. So I'm going to label it P. That's step 2. I promise you, it doesn't matter. It doesn't matter where the P is. We just need there. What's step 3? To the x-axis, because it's going to create a right triangle. What's step 4? Determine the reference angle. Now the reference angle, as it was on the previous slide, said that it was what type of angle? An acute angle, which means it needs to be in between 0 and 90. And considering that I've already covered 120 degrees going in the counterclockwise direction to create this angle, how many degrees is this? And you know that because since there's 180 right here, that's 60 degrees difference between where the terminal side ended and the x-axis. Yes? Okay. What step was that? 4. No? Step 4? Okay, and then, I have to find the lengths of each side. Now this right here, this is very much SAT based and focused. Okay? Do y'all remember special right triangles from geometry? Kind of. There were two types of special right triangles. What were they? 90, 60, 30, or 30, 60, 90. 45, 45, 90. Now, I think it would be best if you guys kind of put this somewhere nearby, okay? So in that way you have it as a reference, okay? Because in order to be able to do these, we're going to need to know exactly that ratio, that breakdown of the 30, 60, 90 and the 45, 45, 90 of the special right triangles. Okay? Does anybody happen to remember, perchance? No? Nobody remembers? The ratio between all the sides and the special right triangles? There's a 1 in here. Okay. The side across from the 30 in a special right triangle was 1. Sometimes it was labeled as an X. The side across from your 60 degrees was labeled the square root of 3, or X square root of 3. And then your hypotenuse was labeled 2, or 2x. It was depending on what version you were taught or what textbook you're looking at. Okay, but this is the ratio that compares all the sides. The side across from your hypotenuse was always twice as long as the side across from your smallest angle. And then the side across from your 60 was always like your smallest side times the square root of 3. And your 45, 45, 90 degree triangle, since these two angles are congruent, that meant that these two sides were congruent. So both of these were labeled 1, or X, and your hypotenuse was the square root of 2. This is old geometry special right triangles. This is also in the SAT and it's in the ACT. And being able to know and recognize those side links, which is going to help you out. SAT is given to you, ACT it's not. So, depending on what test you take, it might be given to you. So now that we have that written down, we're able to label the sides of our triangle now back in our problem. Yes? So these are basically the proportions, how the sides compare to each other. And it's always this for a 30, 60, 90 degree triangle. Always, always. And these are your special ones because there's nothing like this for any other type of right triangle. So if it was like, say it was 20 and 70 instead, there's no special formula ratio for your side lengths. The shortest side, the side across from the smallest angle, yes. We're in every 30, 60, 90 degree triangle. Oh, because it's half the length of the hypotenuse. So when you divide 2 by 2, you get 1. Mm-hmm. Yeah, there's only these two. There's only two types of specials. No extras. Now I can label my triangle knowing that information. Because if this angle is 60 and this angle is 90, I know that top angle is 30. Okay? Which means I can label my sides based off of my special right triangles. The side across from my 30 is labeled 1. The side across from my 60 is labeled square root of 3. And the side across from my 90 is labeled 2. Now the last part of step 4 says to adjust the signs if necessary. In the second quadrant, isn't this X value? So then this should be a -1. Because in the second quadrant, all these X coordinates are negative. All the Y's are positive in the second quadrant. So now that we have our sides labeled, we're able to actually evaluate the cosine of 120. Cosine is what over what? Adjacent over hypotenuse, or the new terms that we learned? X over R from the other side. So if cosine equals X over R, what's X in this problem? -1, and R, 2. R represents your hypotenuse. Or if you want to keep it as adjacent over hypotenuse, that's fine. Just trying to get y'all to see other ways that it is. But there you go. You've evaluated the cosine of 120. Questions? Let's do another one. No. Remember how I told you there's a unit circle? There's 65 things that you need to know. 120 is one of those things that you need to know in the unit circle, and 1/2 is another thing that you need to know. So far, y'all have learned 2 out of the 65 things that are on that circle. All right? I think it's 65. It might be 66. I haven't counted in a while. All right, here we go. 315. Step 1. Draw the angle standard position. So I know I need my initial on the positive x-axis, but where and in what quadrant is 315? Quadrant 4. Okay? So this right here, starting positive x-axis going counterclockwise, that's 315 degrees. Because this here is 270 degrees. So we know it's bigger than 270, but smaller than 360 once we've gone that full circle. So basically, we're taking a circle and breaking it down into quarters. That's where those things came from. Step 2 is to find the reference angle, right? Or, the point P, sorry. So I'm picking a point P and then drawing a perpendicular to create a right triangle. Now I need my reference angle. That's the angle that's going to lie right in here. It's going to be 45 degrees. You get that from doing 360 minus 315 because you're in the 4th quadrant. That's how far you are from the x-axis. Reference angles always come from the x-axis, never the y. It's kind of like angles of elevation, depression. They always come from a horizontal line. Yes. Label the sides. 1 on the x-axis. Y is -1 on the y. It's below the x-axis, so it's negative. And then my hypotenuse? Square root of 2. So now that I have my sides labeled and I've adjusted my sides accordingly to being in the correct quadrant, tangent is y over x. What's my y value? And my x value? So the answer is -1. No, not really. I mean, if you know all your, opposite over hypotenuse and so on and so forth, then you'll be fine. You just learned 2 more things. Now you know 4 out of those 65 things. Questions on evaluating trig functions so far? Y'all okay? We lost anybody? Where's the air? Jesus. Did everybody write this down? Okay. I mean, you'll need it. And trust me, when you're doing these, when you're evaluating the trig functions, like so, it's going to be one of these 2 triangles. Okay? Just make sure you label your sides correctly depending on where the angle is. So, let's evaluate trig functions determined by a point. The signs of the quadrants. Okay? Kind of already talked about this a little bit, but not in full detail. The signs of the trig functions change depending on what quadrant they are in. Okay, all reciprocal functions have the same sign as their original counterparts. Okay, in the first quadrant, both your x and your y values are positive. So that means sine, cosine, tangent are all positive, which means their reciprocals are all positive as well. In the second quadrant, Oh, you already have them on there. Okay, cool. All these are positive. In the second quadrant, your x coordinate is negative, so that means that cosine is going to be negative. All the other ones are positive, except what reciprocal function is also going to be negative? You're right. This one, sorry. Sorry, only sine is going to be positive. So what reciprocal function is also going to be positive? Not cotangent. Cosecant. Because cosecant is the reciprocal of sine. So both sine and cosecant are going to be positive in the second quadrant. All the other ones are going to be negative. In the third quadrant, both x and y are negative, so then that means that sine is going to be negative, cosine is going to be negative, but tangent is the only positive one, because tangent is y over x. So if y is negative and x is negative, a negative divided by a negative is a what? Which means what other reciprocal function is positive? Cotangent. And then in the last quadrant, quadrant 4, sine is negative, cosine is positive, and tangent is negative. Because again, your x coordinates are positive here. Which means what reciprocal function is positive? Secant. Remember, secant goes with cosine, cosecant goes with sine. The easiest way to remember this is all students take calculus. Because all of them are positive in the first quadrant. Students, S, sine is positive in the second quadrant. Take, T, tangent is positive in the third quadrant, and C, cosine in the fourth quadrant is positive. That's the easiest way to remember that. All students take calculus. Got it? Then let's do this. If you are given a trig function such as sine theta equals 2 over 5, and you're told that tangent is less than 0, you have to find cosine theta and the tangent of theta using this information. Okay? If sine is a positive 2 over 5 and tangent is less than 0, what quadrant are we in? You're in the second quadrant because sine is only positive in what two quadrants? First and second. And out of those two, only one of them has a negative tangent, which is the second quadrant. So to determine the cosine and the tangent of theta, we need to draw a right triangle in the second quadrant and label our sides based off of the fact we know that sine theta is 2 over 5. Sine is what over what? Or y over r. We're going to label our triangle based off of this information. So y is 2, r is 5. And what can we do to find the x value? Pythagorean theorem. All of it ties in together. It all ties in together. So that's going to be x squared plus 2 squared equals 5 squared. X squared is, 5 squared is. To solve this, I subtract. Squared equals what? 21. So to solve this, what do I need to do? Now, this is nothing but an equation. And when you take the square root of both sides in an equation, you have to remember it's what? And which one am I looking for if I'm trying to represent this side of my triangle? The negative. And now that I have all my sides, I can find the cosine of theta and the tangent of theta. What is the cosine of theta? X over R. What's X in this problem? Negative root 21 over 5. And tangent is what over what? Y over X. What's Y? What's X? Now, when the denominator or the numerator is negative, that means the entire fraction is negative. Can I have a square root in the denominator? So I have to what? Yes, it doesn't go away. So my final answer for tangent is going to be a negative 2 square root 21 over 21. How are we doing? And it's still recording. I was so afraid it wasn't recording. It's a lot of information, but you get better with it the more you do it. And really and truly, it's the same thing we've been doing, right? Right triangles, labeling sides, doing the trig ratios. I've added in 3 new ones, but they're just flips of the originals. You okay? All right. Let's wrap this up. Using one trig function to find the others. You can do that. Because at the end of the day, if you're able to determine 2 out of those 3 sides, you can find the third, and then you can do all 6. Okay? So, how to do this? Plot the point, of course, and determine what quadrant the terminal side and reference triangle are in. Just like we did before. Okay, using that information. Then, of course, we can either find R using X and Y, or find X and Y, X or Y, just using Pythagorean theorem, basically. That X squared plus Y squared equals R squared is nothing but Pythagorean theorem. Then find the 6 trig ratios, and of course, we got to watch our signs depending on what quadrant we're in. So, we have a point. Negative 3, negative 4. It's on the terminal side of an angle, and we have to evaluate all 6 trig functions for theta. What quadrant is negative 3 and negative 4 located in? Quadrant 3. So I'm going to go ahead and draw a right triangle, making sure that my perpendicular side goes to my x-axis, and my theta is in between my x-axis and my terminal side. Now, because this is the point negative 3 comma negative 4, I already know the 2 legs of this right triangle. Because remember, I went over from the origin to get to the point negative 3 and down to negative 4. So the point actually gives you your 2 sides of your right triangle. And then, of course, you can use Pythagorean theorem to find your hypotenuse, which is 5. Your hypotenuse is always positive. Think about when you square negative 3 and negative 4, you get a positive number. So it's always going to be positive. And now that I have that, I can find each one of my 6 trig functions. I can find sine theta, cosine theta, tangent theta, and so on and so forth. What is the sine of theta? Negative 4 over 5. Because remember, sine is y over r. Your y value is negative 4. Your r is 5. What's the cosine of theta? because cosine is x over r, so it's negative 3 over 5. What's your tangent? 4 over 3. Not negative 4 over negative 3, because a negative divided by a negative is a, and it should, because remember, in the third quadrant, that's the take of all students take calculus, so tangent should be the positive. These, once you've done these are just the flips. What's cosecant? Negative 5/4, secant, negative 5/3, and cotangent, because all you do is you're taking their counterparts and flipping them. And that, dear students, is how you evaluate trig functions of any angle or any point. It's a lot, but when you really think about it, it's like the same thing, just in a different box. Okay? You can do this.